All right, let's get right into it. We're about to declassify exactly why your voice assistant is basically useless for simple real-world tasks. And more importantly, we're going to reveal the production-grade architecture that finally lets it see.
And look, this isn't about the AI not being smart enough or needing a bigger model. No, the failure here is way more fundamental. It's a problem with the architecture, a massive mismatch between how we see the world and how we're forced to describe it.
This quote just nails it. It gets right to the heart of the problem. Think about it. We're forcing a system to understand a complex 3D world through a tiny, one-dimensional keyhole. We're telling it to paint a picture using nothing but a tiny, slow drip of words. So let's unpack what that really means for us.
Okay, so to fix this, first we have to understand the core vulnerability. And spoiler alert, it's not the AI's brain. The problem is the communication channel we forced it to use.
Okay, here's the absolute heart of it. Your eyes, they process a staggering amount of data all at once. Color, shape, depth, motion. It's all parallel. But voice, it's sequential. It's like trying to describe a movie frame by frame, pixel by pixel. It's incredibly low bandwidth. So when we make a user describe a complex physical scene, what we're really doing is forcing them to flatten that rich, 3D world into a slow, single-file line of words. The AI isn't doing the heavy lifting here. You are. The system is shifting the entire cognitive load right onto your shoulders.
And what's crazy is you can see the real-world consequences right here. These voice-only systems, they fall apart with even basic spatial tasks. They literally can't tell left from right, they can't count things reliably, they don't get what behind something means. This pushes users into something psychologists call verbal overshadowing, where the very act of describing something makes you worse at remembering it. It's a system that's literally designed to fail.
All right, before we jump into the fix, just a quick heads up. This channel is for engineers who are building real production-grade systems. If that sounds like you, you're definitely going to want to stick around for this architecture breakdown. We're building a serious community of builders here at Lalit Official.
Okay, we've identified the vulnerability. Now it's time to declassify the solution. This is the blueprint for building a secure, high-performance system that actually works.
Okay, rule number 1, the absolute non-negotiable directive. Protect the latency budget. For any interaction to feel real-time, you've got to stay under about 300 milliseconds. Anything more than that and it just feels broken. It shatters the illusion. So protecting this budget, it's not a feature, it's the entire mission.
So how do we do it? How do we protect that budget? Well, the first step is going to sound a little weird. You do not stream full HD video. Forget 30 or 60 frames per second, it's a total waste of resources. Why? Because most frames are almost identical to the last one. So you get smart. You sample frames intelligently, maybe just 1 per second is all you need. Then you compress it like crazy on the client side before you send it. You package it all up and shoot it over a persistent WebSocket. And this is critical. You have to engineer for backpressure. That just means the server can tell the client, whoa, slow down if it's getting overloaded. That's what stops the whole thing from grinding to a halt.
This kind of architecture works by splitting the system into 2 distinct parts, or planes. You have the media plane. Think of this as the dumb pipes. It's just for moving the high-volume data around, the video frames and audio. But then you have the control plane. This is the brain. This is where the security, the logic, and all the state management happens.
Now, this control plane is usually a Python proxy, and its job is absolutely critical. Think of it as a security checkpoint. It authenticates the user. It holds onto your precious API keys so they are never exposed to the outside world. It checks and sanitizes any request to make sure nothing malicious is going on. And it keeps track of the conversation history. It is the gatekeeper for every single interaction.
And this right here is exactly why that proxy is non-negotiable. Let me be clear. Exposing an LLM API key in a client-side app like a browser or a mobile app is a catastrophic security vulnerability. It's not a question of if it will be exploited, but when. It's a rookie mistake that can cost you a fortune. A proper control plane makes that impossible. So, you've got your low-latency media plane, you've got your secure control plane. What does all this work actually get us? What incredible capability does it unlock? Well, it unlocks the ability for the AI to truly look and talk. What we're talking about here is a concept called visual grounding. All that means is the AI can finally connect its words to what it's actually seeing. It can anchor its language in visual evidence. It's the fundamental difference between just guessing based on your words and actually seeing what you're talking about.
And here's a perfect example of what that means in the real world. A blind AI might guess and say, yeah, the person is near the door. Vague, right? But a
A system with visual grounding, maybe one that's also using depth sensor data from your phone, can give you a hard fact. The person is 3.02 meters from your current position. That is a world of difference. That kind of precision is only possible when you build the architecture correctly.
And once you have this capability, suddenly you unlock these incredibly powerful real-world applications. We're talking about guiding a field technician through a complicated repair, step by step, running real-time maintenance checks, automating on-site inspection workflows. All that complex engineering we just talked about, this is where it becomes tangible. This is where it becomes incredibly valuable.
All right, mission debrief. Let's boil this all down. Here's the key intelligence you need to walk away with if you're serious about building production-ready vision AI.
So let's look at the common mistakes versus the correct protocol. Mistake number 1, thinking you can fix spatial problems with better prompts. You can't. The right move? Use vision to take the cognitive load off your user. Mistake number 2, streaming full high-def video. Don't do it. Instead, use intelligent frame sampling to protect your latency budget. And the big one, exposing API keys on the front end. Never, ever do this. The protocol is to use a Python proxy to secure your control plane, period.
Look, if you remember only one thing from this entire briefing, make it this. A look and talk system is a distributed, real-time system. It is not just a chatbot with a camera duct taped to it. It's a completely different engineering discipline, and you have to treat it that way.
And that's the briefing. Your final directives are simple. Share this intelligence with other engineers who are building these systems. Hit the like button to support the channel, and subscribe to Lalit Official to become part of our community. We're aiming for 50 subscribers to kick off our first live deep dive session. Mission complete.